All right, hopefully you have some energy left before dinner or before lunch. So I was in Australia about 6 months ago for work, and there I was kind of touring around talking to different data leaders, and I had a great time there. It was the first time I'd been in Australia. Obviously not as good as New Zealand, but still had a good time. And while I was talking to these different data leaders for these different companies, we talk about what technologies are they using, what does their tool stack look like, what are they using for warehousing, what scale are they operating at, and kind of the makeshift of their teams. And inevitably we'll be talking about what kind of data are they handling. Is some of that data essentially customer data? And of course, some subset of that data would inevitably be customer data, just like it is for most businesses. And because they were handling customer data through these data pipelines and down into whatever they're using for analytics, I would ask them about how do they control access to that information as it's flowing through their data pipelines down in these analytics platforms. And immediately, their entire body language would change, and they'd kind of slump over a little bit and look a little bit sad and depressed. And what would go from sort of a casual conversation about technology would turn into like an hour-long therapy session where they were complaining about sort of the unfair burden that their teams were put under with essentially controlling or policing access to that information. So what we're going to talk about today is why does that end up happening to data teams? Like, where does that kind of come from? What are some of the mistakes that we've made historically when we think about data, and what can we essentially do about that? So if we look at kind of the life of data in any modern system, in the sort of simple, abstract 10,000-foot view, there's kind of two areas or two states that data lives in. So over here on the left, you have sort of your operational transactional layer where applications are served to customers, and you have your transactional databases like your OLTP databases and so on. And for the most part, these systems are relatively locked down from like our employees and from people having direct access. Like, there's not really a reason for somebody within your company to have root level production access to your application database. So we could still have problems when it comes to managing customer data, but for the most part, these are relatively locked down. The only thing that's touching this is essentially the services that need to push and pull data. But over on the right, when we get into essentially the analytics layer, the whole point of aggregating data down into something like a warehouse is to essentially give people access to that data so that they can do something with it. But when some parts of that data is essentially customer data, where it might be regulated, or there's always risk of essentially PII exposure accidentally or on purpose, then access control suddenly starts to become a big challenge, and it sort of puts a lot of burden on how do we give people access while essentially not leading to a place where we're compromised. While all this is going on as well, within any organization, there's lots of different stakeholders that want access to this information, and they all have kind of different requirements. So like support and marketing are gonna have different requirements than like the finance team and the leadership team. And then there's other stakeholders in a big business where you have maybe compliance teams, security teams, privacy teams that are creating essentially on paper policies about who should have access, how long, what's it look like. But they don't necessarily have the technical skills to implement those controls. And then some of these people are also producers of data. So they might be changing the schema upstream, as well as dropping in data into S3 buckets that get picked up on data pipelines. And they're not necessarily telling the people that are sort of in charge of the warehouse about what's going on and what that data contains. So essentially, what ends up happening is you have this trickle-down effect where all this data is flowing down in these systems. People don't really have that much knowledge holistically about what's in there. And data teams end up being the ones that actually have to enforce the technical controls over who has access to that data. And I think that's an unreasonable amount of responsibility to put on these teams. It's not very fun either. Like, raise your hand if you got into engineering so that you could police access to or control access. Like, that's not the fun reason that we did this stuff. We didn't spend time studying computer science and engineering to do that. So I think that's an unreasonable situation. And the other challenge is that we end up kind of trying to balance this equation between maximizing security and privacy while also maximizing utility. So on one extreme, we can essentially give no one access. We can lock the data up, throw it away, the key, and we maximize privacy and security. But is not very useful. Like, why are we storing the data if no one has access? And then the other extreme, we could essentially give everyone access, overprivilege everyone, maximize utility, but then we're always going to be at risk of essentially getting compromised. So every business in the world essentially struggles with where are we in terms of these extremes. And if we essentially control too much access, we end up with a situation where our teams are losing productivity daily and weekly because they can't get access to the data they need to do their job, essentially. And it also creates a lot of shadow IT opportunities because I don't necessarily have access, but I know that Bob has access. And if I ask Bob for his login credentials, now I have access. Or maybe I ask Bob to export the data to a CSV file, share it on Slack, and then I put it into a Google Sheet, and now I have the data that I need. I was in Wellington yesterday. I won't mention who the company was, but I was talking to a very large company there. And that is exactly what is happening at that company. So it creates a lot of these data silos, which again just makes this problem even more trouble for people. And then on the flip side, we can over-grant access, and then we end up essentially in this situation where we end up in the news because of a data breach. And this is a major problem around the world. In 2023, there was more data breaches in that year than any other year in history. And except for this year, in the first 6 months of this year, we passed the number of data breaches in 2023. So we are doing a really good job this year of being terrible at protecting customer data, essentially. And every business is struggling with this, and 70% of those exposed records are a result of essentially misconfigured, overprivileged access to cloud storage. So clearly, there has to be a better way. Like, this can't be the future solution to this problem of essentially like, hey, let's just make people not be able to go on vacation because they have to deal with access control requests from various people in the team. Now, this problem goes beyond even, I think, where it ends up on the responsibility of the data team. It really stems from, I think, a misunderstanding about what customer data is and the value that it has and how it's fundamentally different than other forms of data. So this problem kind of starts essentially at, would you consider this like system here? So this is like an abstraction of any modern system where we have an application front end, database down to analytics. And in reality, it's going to look more complicated, but for the sake of this story, we'll start here. So when we collect customer data, what do we do with it? So we're probably collecting it from some sort of front end of a web application, a mobile app. And they can be things like people's phone number, their picture of their passport, home address, whatever it is. And what we do is essentially we take that information and we pass it downstream through all these systems. And we end up doing it on purpose. We write a copy of it into our database, and we write a copy probably into something like a warehouse, and it ends up in those backups of the systems. But we also end up often creating copies along the way in log files and other systems. So we end up with this huge sensitive data sprawl problem over time, where we don't just have one copy of the data in a database, we have essentially thousands of copies of this information all over the place. And this becomes a problem because most businesses simply lose track of what they're storing and where it's stored over time. And if you don't know where it is or what it is, it makes it pretty hard to protect it, it makes it hard to be compliant, essentially. And it's a little bit like instead of having one copy of my passport that's in the safe in my hotel room, I created like 10,000 copies of that. And I put them all over New Zealand, and then I tried to protect those locations. Like, that is a much harder problem to solve because it's going to take a lot of resourcing, and there's a lot of foot traffic to that. And we end up creating a ton of foot traffic, essentially, to customer data through all these different systems. And then on top of that, we don't really have a holistic technology solution to protecting data across all this place. We end up creating essentially a solution maybe at the database, and then for a log file. So we stitch together through like duct tape and chicken wire a bunch of point solutions to try to protect the data. But inevitably, some of this data ends up unprotected and falls in the wrong hands. We run into this problem. And I think the fundamental problem here is this misunderstanding about customer data and how it's different than regular data. And this is what I call the cheese and the diamond problem. So imagine that in my house I have cheese and my diamonds, and I'm hosting a dinner party. I want all of you to come over. It's a very, very large dinner party. And I want you to have a good time. So I go and I buy some nice cheese, and I want you to be able to come over to my house, go in the refrigerator, get the cheese, fix yourself a snack. But just because I want you to have a good time and have access to my cheese doesn't mean I necessarily want you to have access to my diamonds, because they're valuable, and maybe they even have sentimental value because they're like a family heirloom. But if I put the cheese in the refrigerator next to the diamonds, it's very hard for me to control access to the diamonds in a different way than controlling access to the cheese. And this is essentially what we do with customer data. We put the customer data, which is way more valuable to the person that owns that data, like my personal information, or the business, or essentially to an attacker than something like my favorite color. And we put it essentially in the same place as that data, and we try to control access in a different way. And those technologies are not designed to essentially understand the differences between those two types of data. We understand this when it comes to physical objects, but we haven't figured that out when it comes to essentially ones and zeros. But fundamentally, not all data is created equal. Like some data is just far more valuable. And things like my date of birth, my credit card number, my government ID are going to hurt me a lot more if they get in the wrong hands than something like my favorite color. And also, all of this data, this kind of personal information, carries additional human meaning or semantic meaning that determines sort of the use cases and the rules of engagement with which we need to support when we're designing systems. So that go beyond essentially things like barcodes and timestamps and so on. So if we, as an example, consider like a date of birth. So date of birth isn't just a timestamp. It tells you how old I am, what year I was born, my birthday. It carries additional meaning. And depending on who I am in an organization and what I need to do with it, I need access to different parts of that information. And whatever technology we develop essentially for handling and managing PII, it needs to understand essentially these underlying semantics. Because we call things like phone numbers and passport numbers and credit cards numbers, but if they were actually numbers, we could do something like this where we multiply a phone number by a credit card number, but we never ever do something. It's a nonsensical thing to do. But what we might do essentially is break it up. Essentially, fundamentally, most personal information is actually a data structure, it's not a number. So I might need to decompose something like a phone number into different parts to satisfy different use cases. So maybe my analytics team needs to know the country code so that we can run cohort analysis by country, but they probably don't need the full phone number. And maybe customer support needs the last 4 digits to verify identity, but again, they don't need the full thing. And if I need to communicate with something like Twilio's APIs to send an email or call somebody automatically or programmatically, then that service needs the full phone number. But that's about it. That's about the only use cases of essentially a phone number. We would never take the 7th digit and multiply it by the 2nd digit and divide it by the 5th digit or something like that. So we have to think through essentially these different use cases and break apart personal information and build technology that understands that. And in other places within the tech stack, with certain types of information, we kind of figured some of this stuff out. So if you look at things like passwords or credit cards, we've kind of offloaded a lot of the responsibility of handling that data. So think about passwords. 20 years ago, we used to put passwords in databases in plain text. Is anybody still doing that? Thank you for not raising your hand. Or you just didn't raise it because of your shame. But along the way, we figured out the only thing you need to do with a password, the only utility of it is essentially check to see if it exists. And you can solve that problem by salting and hashing it and essentially matching against that. And then along came things like identity as a service, and now we can offload not just the password, but the entire auth process to companies like Auth0, Dscope, Ping Identity, there's a whole host of them. And what do they give you? They give you essentially an auth code or a token representation of that person. So as a front engineer, all I care about is, okay, this person's logged in and now I can show them the next screen. And the same thing for credit cards. Like most people don't build their own PCI compliant security infrastructure. They offload that responsibility to a payment service provider like Stripe or Adyen or Braintree or some provider like that. And now I'm unburdened from essentially collecting credit card data. And what do I get in exchange? I get a token that acts like a proxy to that data. Kind of like a debit card is a proxy to the money that you have in a bank. And now I can still carry out transactions against the credit card and do the types of things I want to do with it, but I'm not actually touching any of the raw material or taking on that responsibility. And we have to think through those use cases essentially, not just with passwords and credit cards, but all these different forms of data. Now, you might be thinking, well, there's a lot of data there, like how can we possibly do this? And you're right, there is a ton of data. The average business has about 163 terabytes of data. But when it comes to personal information or customer data, the amount of data is actually relatively small. So if you take all the people in the world, 10 PII fields per person, 10 bytes, it's like less than a terabyte it is. But you can almost fit in an iPhone. And if in any individual business, it's probably less than 1% or less than 0.5% of the total data that you're storing. And then amongst that, the amount of individual actual types of data that you're storing about a customer is probably less than 50, maybe less than 100. It's a very finite, constrained search space, essentially. And we figured out some of this type of stuff in other areas of technology. So within hardware, essentially, we have lots of different ways of storing data. And the reason we develop different technology for storing data is essentially the rules of engagement or the use cases dictate the technology that we're going to use. So if we look at something like hardware or something like cold storage, well, there I'm balancing this equation between cost and speed. And I don't really care about speed because it's cold storage. I probably will never have to retrieve it in anyway, but I need a lot of storage and I want to save on the price, so I can use something like tape. But if I'm building a large distributed cache, then I need a lot of speed and I'm gonna have to pay for it and I'll probably have to use something like RAM. Similarly, in the world of databases, we have lots and lots of different types of databases, but they kind of solve different problems. And depending on the problem we're trying to solve, we might use a different technology. So if I want to understand the semantic relationship between concepts, then a vector database is very good at that. But if I want to model essentially the relationships between tables and be able to aggregate across queries, then something like a relational database is a great solution to that problem. And over the last decade, we've started to do similar things with other types of data. So I'd already talked about passwords, but other types of sensitive data like secrets, now we have essentially secrets managers, or encryption keys, we have KMS. And could we use a database to manage secrets and encryption keys? Possibly, but it's probably not the best solution because we need to do things like encryption key rotation, and databases aren't necessarily set up to facilitate that. And if we mess that up, then we don't have access to our data anymore. And this almost happened to PayPal about 20 years ago. And so we built specialized technology that understands essentially the rules of engagement to support those different workflows. And we have to think through, how do we do that for PII? So there's been some step forwards in this. So if you look at companies like Apple, Google, Netflix, a handful of others, companies that arguably have more customer data than almost any business in the world, you don't see them showing up in the news every week for data breaches. Like, you don't see that now the credit card that you store with Apple Cards available on Reddit. So why is that? Like, what are they doing differently than AT&T that's in the news weekly in the United States for data breaches? Well, if you dig into under the covers, what they did was each of these companies independently arrived at the same architectural pattern. And they realized essentially the same thing I'm talking about, that customer data is a special type of data. It has more value and has different set of rules of engagement and use cases to support. So they pioneered this idea of a zero trust PII data privacy vault. And they moved their customer data into these vault architectures to isolate, protect, and govern access to it in a sort of shared service model. And then what ends up happening in their downstream services is essentially just storing like a pointer in the form of a token. And I'll get into the details on this. But they're essentially de-risking the data in all these other places and creating essentially this centralized single source of truth of the customer data. About a year and a half ago, the IEEE came out with this article about the future of privacy engineering. And in that article, it talks about how the future of privacy engineering isn't privacy by design, but it's actually privacy by engineering through this new architectural approach of a data privacy vault. And this picture's taken from that. So the authors of that paper talk about how just like any modern system has sort of these like 7 core components of like an application front end, database, data warehouse, and so forth. If you're collecting customer data, then you need to add essentially an 8th component to that, which is this concept of a data privacy vault. So slowly but surely, this is becoming essentially the emerging standard for handling customer data. So if we go back and look at the system of problems, like what does this help us do? So here, with the fundamental problem is we end up with a lot of customer data all over the place, and we have this huge footprint essentially to try to protect it, and we lose track of it over time. So when we introduce the vault, what we're doing essentially is ideally we're de-identifying the sensitive data as early in the life cycle as possible. So that could be essentially at the front end of an application where we're collecting it. So we essentially move that into the vault, and then the vault transforms that into a pseudo-anonymized token. So there's essentially no mathematical connection between the produced token and the original value. So that way we can essentially pass this token value downstream and store that as a reference, like a pointer to the original value. But now, even if someone gets a hold of it, it doesn't mean anything. And essentially what we've done is we've significantly reduced the traffic area, the foot traffic to this data. It's a fundamental shift in the way of essentially, it's a new architecture. It's like if I had a fistful of diamonds and I threw them out in this room right now, and then I wanted to make sure no one left this room with one of those diamonds, I'm going to need a lot of resources to figure out how to protect those. I'll have to have a bunch of people go find them and then stand by. They got to go on bathroom breaks. Sometimes they need sleep. So I need backups of those people. But if I change fundamentally the nature of that problem, I put my fistful of diamonds in a storage locker in the corner, and then I build a big security perimeter around it and put all my staff around that, I fundamentally changed the nature of that problem and made it much simpler to protect it. That's essentially the fundamental idea here. Now, to make this all possible and not break all the workflows downstream, we need to introduce additional privacy-enhancing technologies, things like polymorphic encryption and tokenization, so we can create essentially these token representations, not just as random things. We can generate them in a way that they're consistently generated, so we preserve query operations, for example. We can preserve the format so the email still looks like an email, or a phone number looks like a phone number, so that if we have expectations in the schema or at API level, we don't break those expectations. We can create things like time-to-live tokens so that they only live for a certain period of time, or even context-preserving tokens that essentially preserve the entity or of the value, like a name or date of birth, but are not the original value. And then essentially the vault acts like the shared service model to transform the data back and forth to support these different sort of dynamic views depending on what we need to do with the data. And because the only thing the vault cares about is customer data, and it understands that those underlying meanings of essentially a date of birth is actually a data structure that has this composable structure, we could create a very simple policy language to control access so that we could control who sees what, when, and where, based around decision, action, resource, redaction, and condition. So we create very simple rules that essentially control access to that data. But for most things, we don't actually need the data. Most operations don't need that information. We can still essentially perform the types of operations we need from an analytics to machine learning perspective directly against the pseudo-anonymized values. And then not just essentially supporting use cases in the analytics layer, we can support this holistically across the stack. So this isn't just a solution for the warehouse, but a solution across the SaaS applications, the transaction layers, and so on. So we can support all the variety of use cases we need to support for business. And then fundamentally what we're doing is essentially not only securing the perimeter, but securing the data itself. Because now within things like our warehouse or an analytics platform, there's no sensitive value within those systems. So in theory, we could open up a lot more access because you're not risking the leaking of PII. And then for the handful of use cases where someone actually needs to know some part of that data, then you could create simple policies to control that access. So a few key takeaways. The key point here is that we need to understand that PII or personal information is very different than essentially something like my favorite color. It carries a lot more value and it has a different set of rules of engagement than other forms of data. And because of that, we essentially need to isolate and protect it in a different way using different technology that's decoupled from conventional storage, because conventional storage is not designed to solve for those different use cases. And those different tools essentially should be storing pointers to the data, not the original data. And then the reality is that most use cases, just like we don't need the password, most of the time we don't even need this data to support the workflows that we need. It's a little bit like when you call like your Uber driver, you don't see the Uber driver's phone number, they don't see your phone number, but the phone call still takes place. You see a phone number, but that phone number is a proxy. That is a stand-in for the original phone number, but the call still happens. So we could essentially solve all these different use cases with careful thinking. So last thing I'll say is that, like diamonds, PII is very special, so we need to treat it that way, and it's very, very valuable to essentially the person, the business, and potentially the attacker. All right, well, thank you so much.